In this Chapter 32 video, we're going to explain the relationship between two variables. Here are our objectives. We're going to describe how changes in one quantity affect changes to another quantity. We're going to demonstrate knowledge that a variable represents a set of potential values. We're going to identify positive and negative covariance, and then we're going to identify dependent and independent variables. The concept of a variable is one of the most important and powerful ideas in mathematics. Variables allow us to work with both known and unknown quantities. A variable represents a quantity that can truly vary. Much of your work will involve the relationship of two variables and how the change in one causes a change in the other. Being able to mathematically describe or interpret this dynamic relationship between two variables is essential for your success on this TEAS test. Now, before we go any further, let's talk about a few key terms. We need to understand what covariance means. It's the way two variables change together. We need to talk about a dependent variable and an independent variable. We're going to do that in a few moments when we get to the video. But covariance is the way two variables change together. If as one variable increases, the other one increases as well, we say they have a positive covariance and the variables are directly related. If as one variable increases, the other one decreases, we say that we have a negative covariance and the variables are inversely related. In the TEAS textbook, you're going to see correlation, and you're also going to see covariance. In this particular example, for every hour you work, the money you earn increases for that pay period. The time is a quantity that varies. We can represent it with a variable. So let's let T equal the number of hours worked. In between pay periods, the money you earn varies, and it can be represented by a different variable. So let M equal the money earned from working. So as we say, as T, or our hours worked, increases, M, the money we earn, increases also. So the two variables T and M are positively or directly related. In this second example, we have the monthly bills decrease when I work. And when I work, I always pay my monthly bill. So we see as the money I earn increases, your monthly bills decreases. So let's let M equal the money earned from working. Let B equal the balance of monthly bills. As M increases, you make more money. B decreases, the bills we owe decreases. So the variables M and B are negatively or inversely related. Now we're going to talk about the dependent variable and the independent variable. The dependent variable is a variable that is dependent on at least one other variable. And the independent variable is a variable that determines the value of another variable. In your TEAS textbook, you'll see that one variable depends on another variable. When the first quantity changes, the second quantity changes in response. The first quantity is called the independent variable, and the second quantity is called the dependent variable. So we're going to see an example down here. As the temperature of a glass of water decreases, the speed at which water molecules move also decreases. So the temperature is the independent variable, and the molecule speed is a dependent variable. So as our speed increases, our temperature or travel time decreases. This is an example of that. In this example in your handout packet, we have 1, 2, 3, 4, 5, 6. These are the gallons used. We're going to determine the miles driven per gallon of fuel used in a vehicle. So here I have the gallons used. Here I have the miles driven. It goes from 0 to 20 to 40 to 60 and multiples of 20 on up. So if I have 1 gallon of gas, I can drive 16. If I have 2 gallons of gas, I can drive 32. 3 is 48, 4 is 64, 5 is 80, and 6 is 96. This is a straight line, so my miles per gallon is going to be a linear equation, straight miles, going up at 16 miles for every gallon. So if I look up here at my little graph, it says the independent variable is the gallons used. My dependent variable is the miles driven. The reason being is that gallons used, independent variable, is going to determine how many miles I can drive. So the miles driven is the dependent variable. And it's also positive covariance since both variables increase in value and they are directly related. So as the gallons used goes up, so does my miles driven per gallon goes up. Your other example is the average gold price per ounce in US dollars. So as you can see, as the years increase, this is what this on this axis, the US dollars amount decreases. This is what's happened in the last few years for gold. So as gold was at the year 2012, it was $1,669. And then the next year it went down. Next year it went down. Next year it went down. So our independent variable is the year. Our dependent variable is the US dollars, or the amount of gold price per ounce in US dollars per year. This is a negative covariance. It says one variable increases, the year, increases in value while the other decreases. So the price goes down. And the variables are inversely related. Here are a couple of other little examples. As the price of a barrel of oil, X, increases, the price of the gasoline, Y, at the pump increases also. So both the price of the barrel of oil and the price of the gasoline increase. So they are directly related and have positive covariance. Both go up and both increase. But as the price of gasoline increases, the number of miles we travel decreases. So as one increases, the gasoline, the other decreases, the miles we travel. So they are inversely related and have a negative covariance. So just remember, in a dependent and independent variable, one variable depends on another variable. When the first quantity changes, the second quantity changes in response. So the first quantity is the independent variable, and the second quantity is the dependent variable. So in my example up here, the price of the barrel of oil is your independent variable, and the price of the gasoline is a dependent variable. In the second example, the price of the gasoline is the independent variable. The number of miles we travel is the dependent variable. So I hope you are understanding these relationships and how the change in one variable changes another variable. Good luck on this section.